In the controlled integrator network, we can see the elements of a simple integrator with the input and a recurrently connected population A. However, we have also introduced a control signal. As a result, population A has a slightly more sophisticated representation here than in the simple integrator. In particular, this is a two-dimensional representation, where one dimension is the input and the other dimension is the control signal. This allows us to compute the product of the control and the input in the recurrent connection, giving us on-the-fly control over the dynamics of this population of neurons. In the default setup, when we play this simulation, it acts as a standard integrator. So for a given input shown here, we can see that the population A is approximately integrating that input, where, when there is no input, the response remains constant. Resetting the simulator and changing the control signal to be equal to approximately 0 effectively removes the contribution of this recurrent connection, which results in responses that look much like a standard communication channel. So for an identical input, we see that the population A now rapidly decays to 0 when the input is taken away. The only thing governing dynamics in this circuit are the postsynaptic responses of the neurons in A. Resetting the simulation again and choosing a value somewhere in between results in dynamics which are a mixture of feed-through and integration. So for a given input, we see that that value is approximately integrated and begins to decay towards 0, but in a much slower manner than when we have no recurrent connections.